Howdy folks, and welcome back to Advent of Code 2024. Let's take a look at day 14. Alright, someone needs to use a bathroom. The Easter Bunny headquarters doesn't seem like a place we should go. They have improved bathroom security, okay. They have robots, because, they really don't want people using their bathroom. They need to predict where the robots will be in the future. They seem to be moving on the tile floor in straight lines. Okay, your puzzle input is... Okay, current positions and the velocities. Okay, cool. Of each robot, one per line. Okay. Tiles per second. Positive X means the robot's moving to the right, and positive Y means the robot's moving down. Okay, robots are moving. Okay. Example, robots just spaced 11 miles wide in the tile. Okay. Okay, so here's the actual space. So this is the space that we need to work with. For the example space, it's 11 by 7. Okay. They have a unique feature, they can teleport. When a robot would run to the edge of the space they're in there, instead teleport to the other side. Maximum bathroom security, very important, very good. They're effectively wrapping around the edges. Here's what this robot does for the first few seconds. Okay, yeah, so you can see it like wraps around here, wraps around here. We can do that pretty easily with a modulus operator, usually. The story can't wait much longer. You don't have to simulate the robots very long. Where the robots be after 100 seconds. Example above, they look like this. Determine. What are this 1 and 2? Does this mean something specific? Oh, maybe that means like there's 2 robots in that space. Oh yeah, number of robots in each tile. Okay. Okay, so count the number of robots in each quadrant. Okay, so simulate to 100 seconds. Then count the number of robots in each quadrant after 100 seconds. Robots are exactly in the middle. Don't count as being in any quadrant, so the only relevant robots are here. Okay, 1, 3. Multiplying them together gives you a safety factor of 12. How is... Okay. I mean, this is an interesting problem. I just don't understand how this is going to get the historian to the bathroom. But let's see. Okay, so we're starting off... Let's say the actual value. So in this space, 11 and 7. So we need to go with 11 and 7. So I'm going to take this. Okay. And let's go sample here. And I want to actually put the first line in here as the size of the map that we're working with. So that's going to 11 by 7. 7 by 11. Okay. So that's going to be our map size. Okay. And then after that, points, etc., etc. Kind of similar to what we did last time, actually. So let's just pull that in. And file equals pat join sample. You know what? I'm going to use my process argv again because that actually worked out pretty well last time. Okay, contents equals fs read file sync utf8. Okay. You might wonder why I need this UTF-8. Well, that's just what read file sync requires. Otherwise, it gives you the output as a buffer, which is, I've worked with Node for a long frickin' time, and I still don't fully understand how to work with buffers because I'm just lazy. All right, so let's see here. Let's take a look. Yeah, split it by line. That's perfect. The first line is going to be this. So what we're going to do, I'm actually going to get... Yeah, this could be fun. Width height equals line 0 dot split. We're going to split on the comma, and then we're going to map and we're going to parse it like that. So that's kind of a long, confusing chunk of code. Basically, we take that first line, this one, split it on the comma, which gives us an array of 2 strings, and then we map and parse it. So, and then we use a destructure to pull them out into individual systems. So now we have our width and height. Brought, yeah, equals, okay, and so now for I equals 1, I less than lines.length. All right, and then we'll do the same thing here. I'm actually going to grab position and velocity. Position, velocity equals lines I dot split on a space because these are have a space in between them. Perfect. Okay, so now to get these coordinates, we substring out the first two. So py. I'm going to do something very similar. Position dot substring 2 dot split, comma, and I'm actually going to grab this same map here. So log px. Let's just make sure that that looks right. And we'll run this. Not copy relative path. Oh, what happened? The path is the argument type string. I should. Oh yeah, because I have to pass it in. Okay, cool. That looks like something anyway. Okay, and now we're going to do the same thing for the velocity. The upside of this code is it doesn't take up that many lines. It's also really hard to read though. So if you don't know what it's doing, that's why I don't actually like doing a lot of code like this. But you know, push velocity px, yep, and then position. That is not right. We're going to go with px and py. All right, cool. So that gives us our robots. And hopefully none of them are off the map. Okay, cool. So yep, that gives us our velocity and our position with x and y. Now we need to figure out how to loop over these guys and get something to actually work. So let's see, core robots. The thing is, I don't actually need to know the index, I think, because I don't actually really care that much about the other robots, I think, because they can, according to this, or was it? Yeah, the robots are good at navigating over and under each other due to a bunch of fun things. So they can share the same tile and don't interact with each other. So we don't need to care about their interaction with each other. So what we're going to do is we're going to say, okay, next x equals robot dot position dot x plus robot dot velocity dot x. Okay. Same thing with the y. One thing I noticed is the AI is really good at if you have one thing like this, it'll generate the next one. So now we got to make sure that it doesn't go off the end, right? So next x equals, okay. So here's the thing. If it goes, what happens if you modulus on a negative number? So let's say if I say -5 mod width. -5. Okay, so that doesn't do anything at all. So that won't work for that. So if next x is less than 0, then, so what we do here is we actually can just shift the entire robot over by the width. So we can actually just say next x plus equals width. And that should work. If next y less than 0. And now x equals next x modulus by the width. So that's if it goes over the width, we're going to modulus it back around. And this should have the robot like kind of move around appropriately. Okay, so what I want here is actually, let me get a function to draw map. And then for let y equals 0, y less than y plus plus, and we'll just draw the whole map. Equals 0 with x plus plus and console. Oh no, what was this? It was actually process dot standard out dot right or something. Print. There it is, right. All right, what are they actually doing here? Oh, they're not using any spaces. Okay, so we just won't use spaces. And then here, console.log. All right, so now I want to draw the map. I want to actually draw it before I move them and after, just to make sure that it actually does something that makes sense. Okay, cool. Because I'm not actually doing the robots, right? Let equals dot, and then we'll do the character instead. And then what I want to do is I want to loop through the robots and find out how many are there. Robot count equals 0. 4, robot, and this, I don't actually mind how inefficient this is because this is mostly a debug tool for me. Robot.position.x equals x, and robot.position.y equals y, robot count plus plus. If robot count is above 0, char equals robot, oops. And we hope we never end up in a place where there's more than 9 robots in the space. Okay, does that, this definitely didn't do anything. Does that match what we started out with? It does. It does, okay. So then after we move them, oh, that's why. Position.x, next x, y equals next y, okay. So now they've moved. And, okay. That doesn't entirely tell me if that worked, but they definitely moved. So let's just simulate this over 100 seconds. I'm not using I here, am I? I don't think so. All right, and let's just put that over 100 seconds and let's see what we get as our map. Okay, here's our output. And here's what their output was. See, this is why I like having the outputs, is I can actually validate them. That looks correct. All right, now we gotta drag it in the quadrants, drop it, whatever, pop it, lock it. And our current map is, where did it say how big the map was? 101 by 103. So it is odd. So it means we do have a clear position in the middle, so that we can ignore and figure out the quadrants, right? So let's see. X mid equals width divided by 2. Now, if we take our width of 11 divided by 2, we need to round it up. Do we? No, that doesn't make sense. We actually need to round it. Oh. I think it rounds down, actually, because if we have 11 divided by 2, that's 5. You round it down, it's 5, which is actually the 6th position, which is, let me just grab this for example. 1, 2, 3, 4, 5, 6. So it's this one right here, which I think is in the middle. Okay, cool. So let's math.floor. And then we'll do the same thing for y mid. All right, so now that's our mid. This is what we use to determine what quadrant they're in. And then 0, 0, 0, 0. So I'm just going to put 4 quadrants. Yeah. And then for robot of robots, we'll check what quadrant they are in. If robot.position.x is less than x mid, and robot.position.y is less than y mid, quad 0 plus plus. Else if, so let's do, that'd be this quadrant. This one would be the positive x. Okay. This one will be both of them positive. That'll be 2, and this one will be with the x negative y positive. You might think, well, what about other cases? Well, in the other case, they're on that line, and so I don't want to deal with it. Log console log. There we go. Okay, 1, 3, 1, 4. What do they give here? 1, 3, 1, 4. Their quadrants are a little bit different than mine. Cool, let's sum them. Security equals quads dot reduce. Let's see, accumulator, I'll sum plus num 0. Long is security score. And let's take out the draw map. And this, and I didn't put anything there. Okay, cool. 9. They have a 12. 1, 2. Yeah. Oh, multiplying them together. Read, 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 you know? So this needs to start as 1 then. 12. Okay, cool. Let's check. Okay, so within space, 1 wide, 1 3 tall. Get our input. Whoopsie. Okay, and at the very top, 101 by 103. Okay, let's try this. Okay, it gives us this decently large number. Okay, cool. So let's take a look at our code before we move on. Oh, first of all, when we're pulling in our data, the first line is going to be the width and height. So we get that line, split it, and then turn them into ints. We loop over all the rest of the lines, get position and velocity, which are separated by space, and then basically do the same. We take the substring to cut out the p equals or v equals, because we don't actually really care about that for what we're doing here. Then split and then map again, build that into our robot. We have our draw map helper, which just draws the map of the width and height and how many robots are in each position. Then we just 100 times we simulate this for each robot. We figure out, we get its next x based on velocity. If it went below off the map in either direction, we wrap it back around and set the position. Figure out where our midpoint is based on x and y, or width and height. Loop through all of our robots again, figure out which quadrant they fall into, and then, you know, honestly, what we could do is we don't even need to care about what quadrant. We could just say if they are not on the mid lines, then that actually cares. What happens because for the final result here, we don't care what quadrant they're in. Oh no, we do, because we have to multiply them. Yes, not adding. So yeah, then we multiply them together, and that's our score. Did I spell security wrong? I did. All right, let's take a look at part 2. Oh boy, some notes offered by... What? Very rarely, most of the robots should arrange themselves into a picture of a Christmas tree. What is the fewest number of seconds that must elapse for the robots to display the Easter egg? Okay, so here's the issue that I have with this. I don't know what the person who designed this puzzle thinks a Christmas tree looks like. Because there is the triangle with a little square down, right? That's a Christmas tree. There are branches that you could have. Some of them have little balls, some of them have presents on the tree, sometimes there's a star on top. What is a Christmas tree? What does that look like? The best thing that they could do here is take this particular example here and show me what it would look like when it was a Christmas tree. Like, oh, look, yeah, and so here, after 500 seconds, it displays this pattern. That pattern is kind of, it'd be a little difficult to do. What I would really do to solve this is I would assume it's just a geometric shape, because that's kind of the easiest thing to figure out. So then what you would do is just find out kind of if most of the robots form a line. And what I would do for that is I would say, okay, if I have a line between these points, and I would kind of maybe try to, based on the map, figure out all the possible Christmas trees that could show up on that line. Or you could do between the top robots and the bottom robots, like draw a line between them and how close are all the robots to that. So you can get like the distance, average distance they are from that line, just to find out if they were on the line. And then you can say, okay, yeah, if they've gotten to do that, then, you know, that's a straight line of robots. Very cool. Is that the line we're expecting? Is there another line here that forms a triangle? And if you have those 2 points, you know the equation of the lines, you can actually figure out the angles and figure out if it is a triangle. And honestly, at that point, if I just found a triangle, I'd be happy enough. But then you'd also want to find a rectangle that is tangent to the triangle on the bottom line. I am not gonna lie to you. That is, if I did that, that'd probably take me about an hour and a half to write out the code for that. Especially because I don't have an example. I'm just guessing. So I'm not gonna do this one. We may be at that point where I'm just doing the first one's not getting the second stars, and that's okay. I know my limitations. I know like if someone was paying me, I could probably figure this out, but yeah, I'm not gonna spend a bunch of time on this because I know exactly how long. Well, not exactly. I know this is gonna take me a long time. But if you want to figure that out, I would be very interested to see how you do it and what their idea of a Christmas tree actually is. Thanks for watching, folks. I'll see you next time.